Okay, 2009 Form B, problem 6, gives you the function f is defined by the power series f of x equaling 1 plus the quantity x plus 1 plus same quantity squared. Continuing in this manner the general term is defined by x plus 1 to the nth power, and then they also have the same exact expression, just condensed into sigma notation here. And then this is going to be true for all real numbers x for which the series converges. So for part A, it says find the interval of convergence of the power series for f. Justify your answer. You're going to have more than one way to do this. You could enforce the condition of convergence of the ratio test and check endpoints. That's going to be probably more time consuming than what you'd really want. I am hoping that you've been tortured sufficiently with geometric series to the point where when you saw the given function, your brain said, hey, that sucker's geometric, and the common ratio is x plus 1. It's nice if you notice that, because there are all sorts of shortcuts that come with geometric series. And for part A, the shortcut is going to be not enforcing the condition of convergence for the ratio test, and instead just getting the interval of convergence by saying that the common ratio has to be between -1 and 1. And that's going to be the justification of my answer. So for part A, you could say, since the function f is a geometric series, it will converge. Remember, converge just means adds up to something finite when the common ratio is between -1 and +1. So in this case, that would mean that -1 would be less than your common ratio, which they just keep multiplying by x plus 1, and that in turn would have to be less than 1. And then solving for x, just subtracting 1 from all three pieces here, you'd end up with, I think, that. And really, I think as soon as you get to here, I think you've got everything they're looking for. I have a tendency to just kind of make it as obvious as possible. So therefore, the interval of convergence would be x values from -2 to 0. And one really nice thing about noticing that it was geometric and getting the interval of convergence this way is that you wouldn't have any need for not only that ratio test stuff that we've learned in the past, but for this problem, you wouldn't need to do that checking endpoints piece as well. So it saves a lot of time if you can just notice when things are geometric. Okay. Part B, it says the power series above is the Taylor series for f about x equaling -1. Find the sum of the series for f. Well, luckily, we've noticed that this is geometric, so we're going to use the formula that it is equal to your first term divided by 1 minus your common ratio. So, so you could say, hey, this thing would equal your first term, which is 1, divided by 1 minus your common ratio, which is x plus 1. And then I would go ahead and simplify it because it's easy. So it looks like that would just be 1 over -x, like so. And that would be true for all x from -2 to 0. There you go. Okay. Power series, let's see. Find the sum. Okay, so we got it. That's what they're looking for right there. Okay, part C, let g be the function defined by g of x equaling the integral from -1 to x of f of t dt. Find the value of g of -1/2 if it exists, or explain why g of -1/2 cannot be determined. So let's look at that. So first of all, what would g of -1/2 be just based on the definition? They just took the x out, replaced it with a -1/2, and let's do the same thing. Okay, So now let's think about what would f of t be for x values, or I guess I should say t values, from -1 to -1/2. Well, since all the numbers from -1 to -1/2 are included in this interval of convergence, we could say that f of t is exactly the same as -1/x. And I'm going to write that down just to make sure that you can hear what I'm saying here in case that doesn't make sense. Since the interval, so this one from -1 to -1/2 is, and the math notation for is a subset of, is this kind of shape here. So since it's a part of the interval of convergence that we found up above, we can say that f of t is equal to -1/t. So that the function as given is exactly the same as this sum formula that we used here. So if we did that, then we would have that replacement right there. And now we can just follow our antiderivative nose. So, and then plug in upper and lower bounds. And the natural log of 1 is just 0. So we've got it. There we go. Okay. Now for part D, it says, let h be the function defined by h of x equaling f of the quantity x squared minus 1. Find the first three non-zero terms and the general term of the Taylor series for h about x equals 0, and find the value of h of 1/2. So first let's look at finding what h of x is. So I'm going to copy down the most important piece of information that they gave me. It's just the relationship between this new function h and the one we've been working with, f. And they're saying h of x is just f with x squared minus 1 substituted in for all of the x's. So you could, if you want, you could go, to here, and you could substitute it in the term-by-term piece. And so I think that's what I'll do. So we would end up with, your first term would still be 1. And then I'm going to write the first one out, but then I'm going to probably go a little quicker on the other ones. So you'd have x squared minus 1 plus 1. Well, what is x squared minus 1 plus 1? It's just x squared. So from here on out, for that, I'm just going to replace something that's like that with x squared. So then we'd have plus, and then again, x squared minus 1 plus 1 is another x squared. But it would be squared, and so on. And they said the general terms. Let's go here. You'd have x squared to the nth. And then you'd have more terms after that. Okay, so I'll simplify it. You'd have 1 plus x squared squared, or x to the 4th. And then your general term would be x squared to the nth, or x to the 2n. Like that. Okay, so this is the first thing they asked me for. I'm just going to box it up to make it official. First three non-zero terms and the general term for h of x. Now they want to know, what would h of 1/2 be? Well, let's just take all the x's out and replace them with 1/2. And I would definitely say that this problem has a pretty obvious theme. It's all about geometric series. So I do hope, again, you've been sufficiently tortured with geometric series to notice that this is 1. Its first term is 1. Its common ratio is 1/4, or 1/2 squared. And it also converges to first term over 1 minus your common ratio. And then if you simplify this, I believe you end up with 4/3. And then you could say h of 1/2 would be 4/3. you'd be done.